Let me start. So the topic is testing your web apps on ISP.NET. So I am Vitaly Honcharuk, and I'm a full-stack software engineer, and I mostly work with C#, .NET, Angular, SQL, and Azure. I have more than 8 years of experience, okay, the goals for today's topic. So we are going to get acquainted with the testing pyramid, and we are going to understand different software testing types, software testing methodologies, and get acquainted with BDD. So in case somebody didn't hear about it. So if to go in general about software testing, so here is a testing pyramid. I hope you guys heard about this, and if not, so let's go through it. So it's described the different levels of testing that like ideally should be present in your project. Manual testing should be less than 10%, or even don't exist on your projects. And also sometimes in case it's like a big projects, there should be automated GUI tests, and this ideally should be performed by automation engineers. And if to speak about automated API tests, also we have like 3 levels of integration testing, and one of them it's automated API tests, automated integration tests, and automated component test. And usually all of them done by software developers, and some of them, like API tests, can be done by QA automation engineers. And surely, like we probably in almost all projects, we have unit tests, and it's also usually done by software developers. And what I want to mention also that if to look at this pyramid here at the bottom, we can see that if we go down by this pyramid, we see that there are much more surface. So it's like a little. It's like more unit. For example, unit tests. We have much more than integration tests, and integration tests more complex, and it's. Okay, if to look from other perspective, here at the bottom, we see that tests amount is on this axis, and the fragility and coverage and implement is on this side. So if to go a little bit deeper into it, we can understand that integration tests can cover much more components at the same time as unit tests cover only some single components. And many developers know that we can't create a lot of integration tests without stable environments, because integration tests always depending on the environments, and that is why it requires a lot of effort actually to create it, to support, and when it uses real database, it takes much more time, and it's more fragile. So let's go probably to another slide and speak a little bit more about what I've noticed. So on small non-tech companies, usually I don't see like a separate software testing role. so software developers test their own code. So I guess it's not applicable for, for building great software, because software developers should not test their own code. But in like non-tech companies, like managers may not fully understand about necessity of having the separate role to even have more than one developer, more than one engineer to test each other code and implementation. And also, in many projects, lack of unit integration and automation tests, or they like these projects can even don't have tests. So this leads to manual testing, and this has really long-term implications. Actually, let's go to this slide first. So if to see on this slide, like on this axis, we can see okay, on the blue axis, sorry, on the blue line, we can see like manual effort for doing testing. But on the orange line, sorry, forget for on the orange line, we have like automated testing. And if to analyze this, we can see that integration or automation testing, it requires much more effort at the beginning. That is why in most of the cases, teams decided to not to start creating unit tests, integration tests, and automation tests. But after some time, when a project grows a lot, and while it's growing, the manual testing effort become much grows also. And at some point, cost of manual testing and regression will be equivalent or start being even higher than having automated and integration tests. And this brings in my mind the idea that many teams should estimate, should include to the estimate of project development the time to create environments and all required for integration tests and automated tests in case it's really needed. So that is why this point will be never met, because in case team will spend half of the sprint or the whole sprint to create, to prepare everything to have integration tests and automation tests, they will not spend time on manual testing a lot like this, like here. So and if to see, also in the how to say, so if to dig into the cost of the bug, if you will write this query to Google, you will find such table in the Wikipedia. And here you can see that it's like approximate estimation of the cost of the bug when it's found. So in case bug found on the requirement stage, this will cost 1x. And in case this will be found on the post-release phase, it will cost 10 to 100 times even more than it's found on the requirement stage. So and really cost to fix will be really high in this post-release stage. And here, like, you can see and get some ideas when should be found the bugs. So definitely on the requirement stage. And from my experience in many projects, there are many issues, many problems with the requirement stage. And I think the most like a lot of bugs came from there. A lot of communication effort involves because in case requirements are not clear, developers often start like creating additional groomings, additional meetings, communicate between each other, and try to find the truth. Where is the real requirement? And actually, this is a pain for many projects. So let me read through what did you write in the comments. Maybe there are some questions. Yeah, thanks for welcoming me. So here is a question about usability testing. Actually, usability testing, it's more about QA specialty, but here I am speaking about like more programming testing, like unit tests, integration tests, and a little bit more. So here is like a full, probably almost a full hierarchy of testing, and here we can find a lot of different like testing testing methodologies, testing, how to say it, okay, different testing ways. And we will not dig into it and continue to integration testing. So we have different ways of integration testing that I actually already mentioned. And if to speak about simple integration testing, it's usually done by developers. And so integration tests, they need it needed for test a bunch of code nodes and components. So for example, business logic along with database calls and calls to other services in case it's actually needed. And this is like almost the same as unit tests, but with some real implementation. So it can be tested partially as a system, because always when you have, for example, a bunch of microservices that are dependent between each other, and it's probably easier to test 1 to 2 to 3, for example, services, and mock some dependencies to some other services. And if to speak about API testing, it can be done by developers and by QA automation engineers. And in this case, like actually testing API, this is required for testing API for expected behavior, for example, with REST API calls. And it may be implemented on C# and in the same way as unit tests, or any other language can be used with which actually has testing frameworks like NUnit, like XUnit we have in C#. And what also I need to mention that this probably will require to have a QA API. Actually, what does it mean? In different cases, for example, for creation scenarios, we may have like creator and endpoint, but for example, for getting this data, we may not have this endpoint, or and that should be probably created in separate QA APIs that will be only visible for like testing environments, for development environments, but hidden on production. And yeah, same probably will be required in case you for example, case when you have some special system notifications that should be created for user once some, for example, event in the system appears, and this case cannot be easily replicated, and this will definitely require to create some test QA API to create such notifications on demand for tests. So I'm reading through your comments. Yeah, that's true about Selenium. Selenium is cool things. Yeah, and yeah, let me tell a little bit more about it. So automated UI testing, it's probably another way to do integration testing, and this can be done by developers and by QA automations. But usually, from my experience, it's usually done by QA automation engineers. Because it requires, again, to have a separate QA API to get to expose more data from the database to make assertions and so on, and this can be done. These automation tests can be done by Selenium or Tosca framework. Tosca, it's pretty new one that is really awesome, but costs a lot. So yeah, let's go to the next slide. And restrictions to the integration tests in comparing with unit tests, it's probably I already mentioned, it's take more effort to implement and support, and it's very strict to test in environments and third-party integrations, and also it's very strict to existing database version and existing data. So it's not easy to have lots of integration tests. And if to speak a little bit more about how we can do integration tests on in C#, and especially in XUnit, there are some small tips that may be useful. So from my experience, I found that sometimes for integration tests, we use in-memory database in case we use entity framework, and this can be a little bit tricky because with in-memory database, LINQ will not be translated to real SQL, and this may cause fail. It may really fail on the real database, for example, in production. In case on testing environments, you use in-memory database. That is why ideal way or to eliminate this issue, you can do integration tests on the, for example, SQLite or on any real database. So yeah, and other tip for actually XUnit to have. For example, to share the context between different tests, you can use a constructor and dispose it for each test. And if you want to share context for different tests in the same class, you can use class fixture. And to share all the to share context with, for example, database or other connections or other useful things, you can use collection fixture, and this will be easy to use for several classes. Also, other way how to do integration testing in C# in .NET applications, you can use Microsoft ASP.NET Core MVC testing package. And This is a very useful thing when you want to run the server and replace some dependencies. So let me go deeper into it. So this such integration tests requires to have a test project that will contain all the tests, and this will be an entry point for running tests. Sorry. And this test project will have a reference to system under test. So in our case, it may be some web application. And this test project will create a web host for the system, and will use a test server and client to handle requests and response with this system. And this test runner will be used to execute the test and report to the test results. And actually, this package doing everything under the hood for this scenario, and it actually copies dependencies to dependencies file to the folder, and this sorry. So it will copy all the dependencies in the bin directory. Then it will set the content root to the web application project root. So the static files and pages views will be found for the tests and will be executed. And this library provides a web application factory class that will be easily used to streamline and bootstrapping the system web application with test server. And actually, I will try to show, in case I will have time for this, and yeah, let me just continue. Yeah, the cooler thing that I found from this library is that, along with creating a test server and providing a client for it under the hood, you can actually provide stubs for third-party services and check your system partially integrated to your environment. And yeah, this is awesome. And if to speak about as a way of integration testing, yeah, as already mentioned, we can do automated UI testing with Selenium. And this is end-to-end test tool, and it's usually a tester's tools, but yeah, it can be useful for software developers to understand how does it work. And if to speak briefly about it, Selenium has different different languages support, and C# that is awesome for us. And this actually, Selenium uses web browser driver, and for example, in case we use Chrome, it just operate with this browser driver and open a real browser, and then it make swipes and find objects on the page, like components, HTML tags, so by CSS selectors and so on, and how to say, interact with the page like a real user. And it can wait while some parts uploading, while some Ajax calls doing, and so also we can put a flag that we want to see or hide actually actual browser, and probably it will be faster to to have multiple threads running with Chrome driver, and in this case, probably you will want to hide the real browser window. So let me read what did you write. So yeah, so Selenium project is definitely like a different project, and it will not be in the same like library in the same project that you have for integration tests. So usually it's like a separate environment, because for this you need to create some abstractions that will handle like your CSS selector to get items that you need. Why we need integration tests? Interesting question. Actually, we needed to be much closer to user scenarios. So integration tests, with integration tests, we can cover more components working together, and in this case, this will be like system will be tested more complex than like by single component. Okay. Yeah, somebody writes it. I love mediator. Yeah, I love too. So let's continue. So behavior-driven development. Let's spend a little bit time on this. So if to speak about BDD, let's probably start from DDD. Actually, domain-driven design, it's like a business subject focused development for every piece of code. So when teams has like DDD in mind, they think and okay, they create common language with all stakeholders, with QA team, and each system part has like more business involved meaning. And if to speak about TDD, test-driven development, this is like tests first and logic second development. So API always, or like different code abstractions covered with tests. And there are, it's like common things that probably all of you already know, but if to go a little bit, how to say, a little bit back, there are always a lot of mess in requirements, and the formulation of complex scenarios, and support and understanding of the implementation details for all involved parties. So BDD came to solve this problem, and behavior-driven development, it's like when coding begins with the requirements written in Gherkin syntaxes, which translated into acceptance tests, which requires to develop a logic to satisfy them. So this when requirements actually, requirements may be written by business stakeholders, and they can do this in some IDE. For example, actually, they can do this in Visual Studio Code with some special plugin for Gherkin syntaxes, or they can use a Visual Studio or some other, I don't know, Cucumber or other IDEs that can support Gherkin. And so once business stakeholders wrote requirements in this syntaxes, they probably should commit this to Git or any other any other system that you use to store your repository. And then these tests can be written by developers or QAs. So I will try to show in case I will have time. Oh, I should be much quicker to, to show you. So then these tests that created by QAs or developers should be read, because they don't have like a system that actually implements the logic, and that is why developers then should implement the logic that will satisfy such tests. As a result, app logic will fully be covered by requirements via integration tests. And yeah, if to see briefly how does it work. So here is Gherkin syntaxes, and here feature name. It's for example, user stories. It can be split on some scenarios, and here is a scenario that like a particular test case that somebody starts a game, and when maker starts a game, then maker waits for breaker to join. So it's it's very similar to arrange, act, and assert. So it's like a given. It's a first part. It's arrange and act and assert. Given its initial state, when its action take place, and then we check in expected outcome. And here how it's look like, and this syntaxes has a lot of other features. So here is a small example of how we can provide more than one hard-coded value, and here can be a table, and there are lots of different other features. And here, how we can see this in the how we can work with this in the Visual Studio. Yeah, so here is a feature file, and we have some Gherkin scenario, and then we go to definition, and in case it doesn't exist, we can generate it, and then it will be generated like empty step. And this step will look like this. So it will have almost the same string here, and this will mean that it provides a value. It can actually get the value from the table that you can create then after this rows. And then you need to implement the logic for this actual step. And here we have already instantiated calculator class instance in this class, and here what we actually add in the first number. And after we implement all the steps in the following way, then surely we should implement the logic of the calculator, because on when syntax on when step we will execute actual calculator action, and this should be implemented to have a green test. Yeah, so the main advantage is a single source of truth. Because requirements will be inbuilt in the project repository, and always actual, since tests are generated on the requirements basis. So as we see, here is requirements written in the Gherkin syntaxes, and here we have already tests. It's a step for a test, and we will have a lot of steps, and we will have tests, and to satisfy these tests, we should have correct logic. Yeah, let me read again. So, okay. Yeah, so for front end, yeah, actually, yeah, we can use different, how to say, frameworks on front end side, like, I don't know, Protractor or some others that I saw here. So it's like front-end unit testing frameworks, and probably you can build their integration tests with it. But I'm not an expert in this area, so I will not answer. Okay. So I hope BDD will come into your mind when you will start a new project, or I hope it will help you. So if to speak about stress testing and load testing, it's a little bit different from integration tests, but it actually, the purpose is to for load tests is to help to understand how system behaves under the expected load. And stress tests, it's help you to understand the upper limit of system capacity using the load beyond the expectation maximum. So when actually, from my experience, from probably 7 projects, I heard only one project that was used load and stress tests. It's probably not a common thing to use, but it's pretty interesting, and you can find actually bottlenecks in very interesting places. And probably if you have projects with pretty high load, you should definitely use load tests and stress tests. And with stress tests, you can find some bottlenecks, and after resolving them, you may probably change your cloud configuration to have less CPU usage, less power of your cloud instance, so you will pay less. Okay, I have about 10 minutes, and let's continue. So here lots of tools that you can use for stress and load testing, but usually it's not a developer usually developers do not do this, and some special people doing this kind of test. So I have pretty less time, pretty small amount of time, and let me go quickly to the project. So here is a project that follows the clean architecture principles, but this is not as a purpose of this speech, and I just want to show the way of testing with API with ASP.NET Core MVC testing. So here we have a test, and here how we can instantiate a client when we use actually this library. Let me just show the test, and then I will go to the web application factory. So it's looks very simple, and here is a client creation, and here we execute our API with just direct URL, and we just do, for example, get async. And here is the response, and we can check is it successful, and status code, and we can deserialize data, and we can check how many items we have in the collection. As I already mentioned in the slides, when we use this ASP.NET MVC testing library, we can have default web application factory, or we can have like our special application factory with our how to say, with overridings of default startup file. So actually here you can see that I'm using startup file that is in the actual web project. And under the hood, this test will create the application host and the client, and also will provide the ability to override for any dependency, any actually any service in your services. So here I am getting the service from the services, and I'm removing it, and then I'm adding again this application DB context and saying that I'm going to use here SQLite instead of default SQL Server. And here, like I am creating a service provider, and here is a scope, and then here I'm creating, I'm getting again DB context, and I'm doing migration here. Then I'm doing some my special things like getting user manager and role manager and creating data there, and then I'm seeding some default data for the tests. So here, how it can be overwritten. So also here is example how to, for example, overwrite or add some, I don't know, dummy implementation of some notification service, for example, in case we don't want to spam our, I don't know, email provider. And yeah, so that's probably it for this test factory, and I'm having probably 4 minutes. So here, how we can do this like very general for lots of classes and reuse it, but here is example how we can redefine for some special test some dependencies. And we can do this directly in this test, and this will actually work. So here is it. And yeah, that's cool, because when you run this, stop lagging. And so once I run this tests, it will create a test server, and it will provide me a client to actually execute it. Yeah. So let's continue to the, it's building. Let's continue to the next probably class. Okay. And here is example a little bit more complex. So here probably I'm missing authorization, but here is how we can see like to-do item creation. For example, at first we create to-do list, then we create to-do item, and all of that we can do with direct post queries. And then we are getting some paginated data from our API with using just simple HTTP calls. And the last thing is again about spec flow. So yeah, tests are successful. Here is it. And last minute. So here is like features, and I can press F12, and I'm going to the direct implementation of this step. And again, I'm going to some other step. And other cool thing that in case we need to implement some new some new scenario, we just copying existing steps that already implemented and just change whatever we need to change. For example, we want to do here something else, and for example, we will check something else. So I will and not implemented steps just shown with this color. And okay, I will not show how we generate it, but it's very easy. And actual steps will look like this. And then you will be able to run your tests from SpecFlow implementation. That's probably it. And so we found our goals, and that's it.